In this program, we'll go over the operation of the ELMAGCO brake, the way it works, and how to maintain it, so that it'll give you long, trouble-free service. This is the model 7838 ELMAGCO brake. It looks a lot like the other two ELMAGCO brakes, the 5032 and 6032 models. All three work on the same principle, but none of them will work without proper maintenance. There are several things you should know about these brakes to keep them from being damaged, and the best way to become familiar with them is to look inside one. So let's take a look. First, the different parts of the brake. This is the rotor, shaft, bearings, and sleeves. The magnet coils, the magnet assemblies, and the case. The way the brake works is like this. These two sets of magnets create an electromagnetic field when electricity is applied. The strength of the magnetic field depends upon how much voltage is used, anywhere from 0 to 240 volts DC. The rotating drum, or rotor, is positioned to turn around the magnets with only a 4/1000 to 5/1000 inch air gap. Naturally, when electricity is applied to the electromagnets, the drum falls right in the path of the magnetic field. This sets up a magnetic field pattern in the drum. When the drum is turned, the disruption of the path of magnetism creates currents known as eddy currents in the drum. These eddy currents set up a magnetic field in the drum which is opposite in polarity to the fields of the electromagnets. These opposing forces produce the braking action. They also produce a lot of heat, which is absorbed by the drum. The heat has to be removed, or it will build up and damage the drum. We use water to carry it off. The water has to flow at 75 gallons a minute in the model 6032 and 5032 in order to keep the brake cool enough to operate. The model 7838 requires a 150-gallon flow rate. The inlet water temperature shouldn't exceed 100 degrees Fahrenheit. The water is pumped in through this 2-inch inlet at the designated flow rate. The system uses a gravity flow return through this 3-inch water outlet. All connecting pipe to the storage tank should be 3-inch pipe or larger. If the return flow is restricted by smaller pipe, or if it gets clogged, the water level will rise inside the brake. When it reaches the bearings, it could wash the lubricating grease out, and then it's only a matter of time. The storage tank has to be big enough to dissipate the heat that it's picked up in the brake before it's circulated back through the brake. A 200-barrel tank will usually be big enough to handle this. If the natural temperature of the area keeps the water temperature hotter than 100 degrees Fahrenheit, a heat exchange system should be installed to help cool the water down before it's pumped into the brake. Since the gap between the drum and magnet is so close, 5/1000 of an inch, it's absolutely necessary that the water be kept clean. Any garbage in the water will get caught in the gap area between the drum and the magnet. And when this happens, it'll cause the brake to seize. A scale buildup can also cause problems, so your water purity is important. If it's impossible to get pure water, and a high-scale content water has to be used, you should treat it with chemicals like the ones used in the engine cooling systems to help retard scale deposits. Now, let's go back over the specifications we've talked about up to this point. This brake uses eddy currents created by moving the drum through a magnetic field. It works by controlling the voltage to regulate the amount of braking needed. The air gap between the drum and the electromagnet is only 5/1000 of an inch wide. The heat created by the brake is carried off by a constant flow of water at 75 gallons a minute on models 5032 and 6032 and 150 gallons a minute on model 7838. The inlet temperature shouldn't get over 100 degrees Fahrenheit, and outlet temperature shouldn't get over 160 degrees Fahrenheit. Outlet water should never be restricted. This will cause the water level to rise inside the brake and could wash the lubricating grease out of the bearing. The storage tank should have a minimum capacity of 200 barrels, and nothing but clean, pure water should be used. If you have to use water with a high scale content, treatment chemicals should be added to help keep scale deposits from forming inside the brake. Basic maintenance on the ELMAGCO brakes should be performed on a regular basis. Let's look at the front of the brake. Here's the water inlet. As we mentioned earlier, the flow rate is important. If the water level gets too high, this water overflow valve will allow it to drain off before it reaches the bearings, as long as it's not clogged. This is the lower magnet cavity drain, which allows condensed moisture inside the magnet cavity to drain off. This is the magnet cavity breather. The drain and the breather on both sides of the brake should be inspected and cleaned out to be sure that they have free access to air. If they're dirty, it'll be necessary to remove them from the brake and clean them with kerosene or some other cleaner. Don't ever try to clean them while they are in the brake. Kerosene and other petroleum products will dissolve the baked-on finish of the coils, which will lead to a coil failure. So don't ever use petroleum-based cleaners to clean inside the coil area. These three plugs are the air gap inspection plugs. Air gap should be measured every month. As we mentioned earlier, when the brake is assembled, there is a 4,000th to 5,000th of an inch clearance between the magnet and the drum. After the brake has been operating for a while, the gap will usually increase a little, but it shouldn't be so wide that the peak torque will be reduced. If there's a scale buildup, you need to take this into consideration when you're determining the effective gap distance. There really is no maximum acceptable air gap, but keep in mind that the greater the gap, the less braking action that you'll get. As the air gap widens, braking efficiency drops off. If a heavy corrosion buildup or erosion of the rotor or magnets occurs, you should check your water for causes and take corrective actions. This should be checked on a regular basis, too. The rotor bearings need to be lubricated pretty often. The grease fittings are located here on both sides of the brake, and both bearings have to be greased. You should add about 2 ounces of grease to each bearing every 24 hours or after each trip. A good grade of lithium or sodium-based ball and roller bearing grease is best, like Shell Alvania No. 2, Texaco Marfax, Mobil Mobilux 2, or Exxon Beacon 2. If you don't keep these bearings greased right, you're going to end up replacing them. When you run into problems with your ELMAGCO brake, first you should determine what's causing them. If you're having water cooling problems, the heat created by the eddy currents is probably causing the rotor to expand. You can tell that this is happening by a noticeable decrease in the efficiency of the unit. And when this happens, you should run the drawworks so it turns the brake at a constant, slow speed. Then the cooling water should be started again. This will help to cool the rotor evenly and hopefully prevent warping or out-of-round conditions. The water temperature entering the brake should never exceed 100 degrees Fahrenheit. If you're having serious internal problems with the brake, like a bad bearing, scale buildup, garbage getting lodged in between the magnet and the rotor, a burned-out coil, or something else that would cause the brake to seize or fail, it'll probably have to be disassembled and repaired. And you should find out the cause of your problem and correct it so that it won't damage your brake again. Your service manual has some excellent suggestions on troubleshooting. Read it and follow the service instructions that it talks about. And keep in mind these ideas that we've gone over in this session. The cooling water has to flow unrestricted from the water outlet to allow the brake to cool itself. Be sure that it's not clogged or restricted. And the magnet cavity breather should be kept clean. Check it once a week, and if it becomes clogged, take it off the brake to clean it. Solvents will eat away at the protective coating covering the magnet if it gets inside the cavity. At least once a month, check the gap between the rotor and the magnet. It should be around 4,000th to 5,000ths of an inch. Remember that the greater the distance, the less braking you'll get out of your unit. And add about 2 ounces of good lithium or sodium-based ball and roller bearing grease each 24 hours or every trip. The grease fitting is located near the rotor shaft, and there is one on each side of the brake. Be on the lookout for problems. Remember that if your brake starts to lose its efficiency, it could be because it's not being cooled enough. Check your flow rate to be sure it's getting plenty of cool water and that the water is draining freely. If you begin to notice a problem developing and you can't figure it out, refer to the diagnostic charts in the maintenance and service section of your service manual. It's a good reference, and it should be able to help you figure out your problem.